Users have asked me to show how the output of this UPS looks when under full load. So I've got a 1.8 kilowatt heating element here, and let's turn this on and see how the output looks. I've got two battery chargers hooked up, supplying 48 volts at about 44 amps. Hopefully that'll be enough to supply it. Let's just put the scope in roll mode so we can see what happens. Plug in the heating element. And we'll flip off the switch. Oh, that didn't work. Let's see what happened here. It looks like the chargers are just not able to supply enough power. The yellow trace is the voltage on the battery, which should be 48 volts. The purple trace is the output, and the blue and green are the inputs to the transformer. So let's try putting a capacitor, a big filter capacitor, on the DC bus to better simulate a battery, so hopefully the voltage won't drop down like this and it may stay up. There's 60,000 microfarad in addition to the about 7,000 microfarad on the board. So let's see how this goes. Turn on the AC. Power. Actually better unplug this because it's going to do its test thing. Come on. Oh, we got to turn on the DC first. There we go. Let it do its self-test, and then we'll try the see how it runs. Load is on. Start the scope, and let's turn off the AC. Nope, still didn't do it. It looked like it ran for longer this time. Yeah, it stayed up for a bit longer, but then it eventually dropped. But while it was working, it produced a pretty decent sine wave. So it looks like we just need some more current. I'll add one more charger on, hopefully that'll be enough power to run continuously. Okay, the third charger is connected up now, so we should have about 62 amps total available now at 48 volts. So let's give this thing a try. Get that running. Plug in the load. And let's cut the AC. Nope, still doesn't work. Still, the voltage just decays over time. Make sure I actually turned on all these chargers. Yes, those are on. And that one is on. Maybe it just needs more power. So I'm going to get out the current probe and see how much current it's actually drawing. Okay, here is the current probe. Looks sort of like a gun. It's just a Hall effect current transducer. So just clamp that around the negative wire going to the UPS. And I hooked it up so the blue channel is at 10 amps per division. So let's give this another shot. Plug in the load and turn off the AC. Oh, we got some big spikes there. Oh wow, that's a lot of current. It's in excess of 70 amps. So let's adjust the scaling. Get 20 amps per division. I can't set that on here. You just have to trust me that it's 20 amps per division. Let's give it another run. let it do its self-test, then we'll plug it in and give it a try. We're registering current. Not all too much. Let's give it a try again. And AC off. So the peak current we're getting is around 4 divisions, so that's 80 amps. So we're going to need quite a bit more power supplies here to get enough power to run this thing. I've now got 4 chargers capable of supplying a total of about 80 amps to this thing, so let's see if it works now. And here we go. Hey, it worked. Stop beeping. Oh, missed the transition. Let's try that again. That was a bit better this time. It did dip, but it came back up and stabilized at about 50 volts. And the waveform, oh, the probe fell off, it looks like, so we don't have the waveform. The current waveform looks rather noisy. I wonder if we've got a ground loop somewhere. Let's try putting a cheater plug in this connection here going to the current probe and see if that fixes it. And the cheater plug's in there now, so the ground's disconnected. And let's give it another try. That's a lot cleaner. And not such a current spike this time either. So the current runs from 0 to about 100 amps or so. And there's the output of the waveform. Very good sine wave even under full load, or pretty much full load. Let's go. I think the waveform will degrade a bit if we decrease the battery voltage. Let's give that a try. Okay, let's give a try lowering the DC bus voltage. Start it up. Try turning it down. It's about 45 volts now. 42. Now it's complaining about low battery. Keep going. And the waveform is becoming more flat top now at about 40 volts. And it shuts down at about 38. Or it hit the current limit and the voltage just dropped out, I'm not sure. But it maintained a pretty good waveform actually. Here's a much better view of what happens when the DC bus voltage lowers. I made this just by turning off one of the power supplies, so the bus collapsed relatively slowly. You can see initially the waveforms stay sinusoidal, and then it starts clipping at the peaks, and as the voltage continues to go down, the duty cycle maxes out on the transformers. They're applying the switches. H-bridge switches are on continuously. That's the maximum voltage it can output. And as the voltage goes farther down, it becomes more like a trapezoidal waveform before finally shutting down. That shut down at about 38 or 28 volts or so. I hope you found this video on the output waveform of this under high load interesting. Thanks for watching.